All right, properties of quadratics. So most of this is review. Just want to point out a couple things. So quadratics have an x squared. They're usually given in one of two forms. So the general form is often given something like this. And then we have vertex form, which is more of my favorite. And that would look like that. So the vertex form has some advantages. You can see the transitions easily, or the transformations, sorry. You can also see the vertex pretty easily, like this one would be at 1, 2. It just gives you a little bit more information, I think. It's not that this doesn't give you any information, it's just easier in vertex form. Generally speaking, we have two types, depending on whether A is positive, which is the number here, or A is negative. It would be the same if it was in vertex form, so the one that I just did. So that's a -3, so for here, A would be a -3, so that would be one of these that opens down. If it's something that opens up, then the function decreases until the vertex, and then it increases, and then this is vice versa. So a function that opens down increases at first, reaches its maximum, and then decreases. So keep in mind that we've already talked about maximums and minimums as well, so that would be the max, that's a min. Right, here are some equations that you need to know, some formulas. Negative b over 2a, so that's the x coordinate for your vertex. I think you should know that one. This one I never use. That just allows you to solve for the y-intercept, or sorry, for the y-coordinate of the vertex. But if I know what the x is, so if you tell me that the vertex occurs at 2, then I'm just going to plug it into f of 2. So that's just a formula that I don't need to have memorized. So what else we got? So it does have an axis of symmetry, and I skipped over that here a little bit, but the axis of symmetry always goes through the vertex. So if, again, we just use 2 there, if I know that the vertex is at axis 2, then the axis of symmetry would actually be the line x equals 2, the line that I just dotted. And that's what this is trying to say over there. So that's why it looks like a vertex. And then we already talked about the other ones. And then we'll do an example. So given an equation, find the vertex and the axis of symmetry. Okay? Well, it's not in vertex form, so I'm going to have to do a little bit of work. So it's a -12 divided by a -2 times 2. So that's 4, the negatives cancel, so the vertex occurs at 3. So the axis of symmetry would be x equals 3. The vertex would be plugging in the 3 into this equation. So -2, 3 squared, plus 12 times 3 minus 13. So that is 9, that's a -18, plus 36 minus 13. So that's a negative, what's that, 21, 31 plus 36, so that is 5. So the vertex occurs at 3, 5. Does it open up or down? Well, that's a negative, so it's going to open down. So if you're not sure where's the function increasing and decreasing, then just sketch it a little bit so it looks a little like this. So initially it's increasing, so it's increasing starting at a -infinity up to the x coordinate of your vertex, because increasing and decreasing only deals with x's, so it's increasing from here to here. And decreasing, once it is at its vertex, it will go and be a decreasing function at that point, so from 3 to infinity. So keep in mind, this only deals with the x values. So I'm not telling you that there is a point -3 on this graph. I'm telling you that from a -infinity to 3, the function is increasing. Okay, domain and range. Well, all quadratics have a domain of all real numbers. The range, that comes back to the vertex a little bit. So that's 3, 5, the vertex. Since it's opening down, the 5 is a maximum. So that means that this graph comes from a -infinity, reaches 5, it does reach it, and then continues or goes back down. Okay? And then I should probably be able to use most of that, or all of this, in terms of graphing it. So what do I know? I know 3, 5 is on there. So 1, 2, 3, 1, 2, 3, 4, 5. And then I can either use transformations, or I can just plug in a point. So sometimes I get stuck on my transformations as well, especially since I'm a little worried now about, well, what happens in terms of order and stuff. So we can just plug in, for example, 2. So at 3 I know I'm at 5. So what happens at 2? So it would be a negative 2 times 2 squared plus 12 times 2 minus 13. So that's 4. So we'll do that over here. So that's a negative 8. 12 times 2 is 24 minus 13. So a negative 8 minus 13 is a negative 21. So at 24, I am going to be at 3. And then the same thing is over here because of the symmetry. So this is why symmetry helps. So if you find one point, you actually have another point. Probably be nice to have intercepts here if they come out nice and even. So let's see what happens at 1. That would be the next one. So it's a negative 2 times 1 squared, it's a negative 2. Plus 12 minus 13, a negative 15 plus 12. Sorry, a negative 15 plus 12 is a negative 3. So I'm already at the negatives at this point. I think I did that right. So it crosses somewhere between crosses somewhere between 1 and 2 and between 4 and 5. Okay? Thank you.